polynomials. Let's say you are trying to add up different variables. Let's say you have x to the power of 3, you have x to the power of 2, you have z to the power of 5, you have a w to the power of, let's say 9. And you're trying to add all of this together. And it may even come with a constant term, let's say 5. This sum is referred to as a polynomial. Please don't be fooled by the positive that we have here. You could have a mixture of positive and negative signs. That is, you can have x cubed minus x squared plus z to the power of 5 plus w to the power of 9 and minus 5. So when you have an arrangement like this, you have basically what we call a polynomial. But one thing is very important, that the power of this variable is not expected to be negative. If it is negative, then it's not a polynomial. For instance, if I write z minus z to the power of negative 3, this cannot be referred to as a polynomial because the power of z here is negative. Now, there are degrees of polynomials. There are several degrees of polynomial. We have degree 1, degree 2, 3, 4, 5, 6, etc. Now, these degrees are determined by the highest degree of the individual term. A lot of degrees that I have said right now, but let me just put that into a better perspective. Take, for instance, we have 4x to the power of 3, and then we have minus 2x to the power of 2, plus 7x, then say plus 5. In this case, we have to inspect the individual term in this expression. We have a constant, positive 5. We have 7x. We have 2x squared. For 7x, we have the power of 1. For 2x squared, we have a power of 2, and this we have to the power of 3. So as you can see that 4x to the power of 3 happens to be the term with the highest degree, so which makes the whole of this polynomial a third degree polynomial. That's third degree. So if it is a second degree polynomial, then it means that we can just say 2x squared plus 7x plus 5. So here we have a second degree polynomial. A second degree polynomial. And also, we can also have 7x plus 5. Right? This type of polynomial is referred to as a fourth degree. Of course, there are other names that you call some of this expression when you find them in other contexts. In other contexts, we can refer to this as a linear expression. This is linear, and this is quadratic, and this is cubic. If you have to the power of 4, you have a quartic. If you have to the power of 5, you have quintic, etc. You would recall at the beginning of this video, I cited this instance to define polynomial. But you're going to notice that in this example, we have different letters coming together. We have x, we have z, and then we have w. These letters don't seem to be uniform. In that case, we are looking at a type of polynomial that we refer to as a multivariate polynomial. Okay, so basically the grammar is just when you have multiple variables, that's what you refer to as multivariate polynomial. But my goal in this lesson is not to explain all of that. It's just to introduce you to polynomials and probably show you some additions and some subtractions, and that's it. Note that polynomials can be added and they can be subtracted one from the other. So if you are given all of this, we have the first polynomial, which is P1, we have the second polynomial, P2, then we have the third polynomial, which is P3. And then you are asked to add the first and the second together. It depends on you. All right. So I'm going to use two approaches for the first one. I'm going to stick to just one approach for the remaining two. So for the first one, P1 plus P2. The first approach is just add it together by putting them inside the parentheses. So for the P1, we have 2x to the power of 3 plus 3x squared plus 5x plus 7. And for P2, I have plus the whole of P2 is x cubed plus x squared minus x, plus x plus 1. So we have 2x cubed plus 3x squared plus 5x plus 7. Now we have to open the parentheses with the positive 1 that is right here, which is invisible. So we just have to open that way as x to the power of 3 plus x squared plus x plus 1. So now our goal is to match them up. So we have a 2 to power of 2x to the power of 3 here. I have to add it to x to the power of 3 because these are the like terms that we have in the expression. The same thing goes with x to the power of 3x to the power of 2 and then x to the power of 2. Then if you look at 5x and then x, then 7 and then 1 together. So if I'm going to be adding now, then I will be taking this and this together. Then I'm going to be having 3x cubed. Then I'll take these and this together. Then I have plus 4x squared. Then 5x and then ordinary x right here. Then that gives me 6x. Then if you take the constant value, which is 7, another constant value, which is 7, I have 8. So this is plus 8. So which means that I can say that P1 plus P2 is equal to all of that. Now I said at the beginning of this video that I'm going to be using two approaches to solve this problem. So the approach is just more like you place the two polynomials on top of one another. That is, P1 goes first. So P1 is going to be 2x cubed plus 3x squared plus 5x and plus 7. And then P2 goes next as x cubed plus x squared plus x plus 1. So because we are adding P1 and P2 get together, we have to add the expressions together as well. So we have a plus 7, and then we are adding that to a plus 1. So it is plus 7 plus 1. So there, what is happening there is plus 7 plus 1. That is going to be a plus 8. So this is going to be plus 8. We have the same thing playing out with 5x and x. So we have a plus 5x plus x. So this is plus 5x plus x. That's 6x. If you do that for the rest, you have plus 4x cubed, 4x squared, and for this we have 3x cubed. Whichever route you choose, you still end up getting to the same destination. So this and this are basically the same. If, however, you're adding P2 and P3 together, I am taking P2 and P3 together because of the fact that I'm trying to explain how to deal with the signs. P2 is x cubed plus x squared plus x plus 1. I am adding that to P3, which is plus 2x, right? So let's try to open the parentheses. I'm trying to use the first approach. So when we do that, we have x cubed plus x squared plus x plus 1. Now we're going to use the positive to open the parentheses, right? So you have plus x cubed minus 2x squared plus 2x. So let's add them up. So this goes with this, and then I have 2x cubed and then x squared, and then we have a negative 2x squared that is going to be minus x squared. Then this and this, you have 3x, and then we are left with just 1. So 1 doesn't seem to have a partner, so you have plus 1. So that's that for p2 plus p3. So for the third one, we have p2 minus 2p1. p2, as we've already known, is x cubed plus x squared plus x plus 1 minus p1. The whole of p1 is 2x cubed plus 3x squared plus 5x plus 7. So what we just do here is to open this parenthesis. So we have a negative 4x cubed. Then we have a negative 6x squared, then negative 10x, negative 14. And all of what we have in front here, x cubed plus x squared plus x plus 1. So let's bring the like terms together. We have this, then we have a negative 4x cubed. So that gives negative 3x cubed. Now this and this, you have this is like 1 minus 6. All right, so you have a minus 5x squared plus x minus 10x. You have minus 9x, and then 1 minus 14 seems to be minus 13. So you can just leave it this way, or since you can say that negative is common all through, you can just bring it out. Then you have the rest of the terms in the parentheses to be all positive.